All right, we're on the second page now. Let's take a look at these. This one starts with some of the circles that we've been working on, but then it goes down into some final exam review, so just be prepared for that. So first of all, it's just first asking from the equation of a circle to identify the center and the radius. And so noticing that the x squared has no number with it, it's going to be just a 0 for the x coordinate, and then the y coordinate is going to be a positive 7 because it's the opposite of whatever is in here, right? So because x has nothing with it, it's like saying x minus 0 squared. Then the radius is going to be the square root of 49. So the radius is 7. Now write the equation of the circle that satisfies each of the conditions. So we're going to plug into the formula x minus h squared, y minus k squared equals r squared. And so I'm going to say x minus a negative 2. Do you see how that turns into a positive 2? Don't forget the squared on the parentheses. Y minus 3 squared. And then the radius is 2, so 2 squared is 4. How'd you do? Did you get that one? All right, next, take out the center and the radius. So center is 15 comma 0. And this time my radius is just root 10. Yes, you can get me the decimal version of that too, but just the square root of 10 is enough. And then again, putting it back into the equation, x minus 12 squared, y minus 9 squared. Root 22 times root 22 is just going to be 22. How'd you do? Next ones have to do with graphing. Let's pull out the center so then we can graph it. Here I'm going to get a 1, negative 1 with a radius of 1. I'm going to really zoom in on this one. So 1, negative 1, and radius of 1. That means you're going a 1 in every direction. Connect it. Are you making way better circles than Miss Sanchez? All right, next one's going to have a negative 4, 0 with a radius of 5. Negative 4, 0, 1, 2, 3, 4, 5. In all directions. And then connect it. Now, given the circle, they want you to make the equation. So the center here is back 1, 2, 3, up 1, 2, 3, 4. And the radius is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we write the equation. X minus a negative 3, y minus 4 equals the radius squared. All right, now we have to do some completing of the square in order for this next part. We're going to start by grouping the x's, grouping the y's, and the constant is already on the side that we want. So doing the b work on the 4, we see that we're going to be adding 4 to both sides in order to complete that square. Doing the b work on the 6 shows that we're going to be adding 9 to both sides. For that, complete the square. So this gives us the x minus 2 squared perfect. And this gives us the y plus 3 squared perfect. And then 12 plus 4 plus 9, do you see that that's going to give us 25? So now I'm able to identify the center and the radius easily from this form of the equation. Pause the video and try the next one on your own. All right, let's see how you did. Start with some grouping. Move that constant over to the other side. So if I added 4 for the first perfect and I added 16 for the second, I'm going to get a total there of 36. And now I can easily see my center and my radius from this form. So how are you doing on these complete the squares? Are you understanding the grouping part? Are you understanding how to add to both sides, etc.? Now this bottom section is a finals review of all the types of equations we should be familiar with. Here's a Math 1 equation where you need to turn the 16 into a base of 4. Well, 4 to the negative 2 power is another way of saying 1/16. Now that I've got the same base, I'm able to do an exponential equation by writing just the powers equal to each other. So I'm going to say that x plus 2 is equal to negative 2x plus 6. Do you see how I'm distributing that? And then let's add 2x's to both sides and minus 2 to this side. So I'm going to get 3x's equals 4. And my final answer is just 4/3. This next one is an absolute value equation. Do you remember these? We know that 2x minus 3 might equal positive 15, but we also know that 2x minus 3 might equal the negative version of that. There's two answers for the absolute value equations. So here's the answer for the first one, and here are the two answers for the second one. All right, this next one, we're going to start by dividing both sides by negative 2, just to get the fifth root isolated. And 6 divided by negative 2 is going to give us negative 3. Now, how do I undo a fifth root of something? I do to the power of 5. Fifth root to a power of 5 is just going to take whatever's inside out. It's like it erases the fifth root. And then I go negative 3 times negative 3 times negative 3 times negative 3 times negative 3. And so 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is that 243. And it is going to be negative because it's an odd power, an odd number of times that we're doing that. So now, final step is that we minus 3 and we get negative 246. Ooh, that one was interesting. All right, this next one is wanting you to set it equal to 0 to start, and then you have a couple options. Do you want to get A, B, and C and do the quadratic formula? Do you want to do complete the square, or do you want to factor it? Well, factoring is always our first method that we should try. And by the way, you can guess and check on this one. You don't have to do the little X and T method. So let's just see if we can come up with it. What times what would equal 3x squared? Do you see that that should be 3x and x? And then we just have two options for the back because it's a prime number of 2. It could be 2 times 1 or it could be 1 times 2. Which one would give us the middle term of a 1? So here I see 3 minus 2. Here I see 6 minus 1. And so I can tell that it should be this first one. And now I just need to decide on signs. So 3x minus 2 or x plus 1, that gives me positive 3 and minus 2. Oops, that's not what I want in the middle. I want the negative to be with the greater one. So that means I need to make this positive 2 and negative 1. How do I know if I chose the right answer? I now would FOIL this answer, first, outer, inner, last, and see if it gives me the original. So this gives me 3x squared minus 3x plus 2x minus 2. I combine the middle term. That is the negative 1x that I want. It is the original. That means that those are my factors. So all this work just to factor it, but they want me to solve this equation. That means after I get the factors and I'm all said and done, it's still equal to 0, and I need to use the zero product property to solve each piece. Set the first factor equal to 0, set the second factor to equal to 0, and solve. One factor is going to be a fraction. and one factor is going to be a whole number. What the heck does this even mean? It means my parabola touches the x-axis at 1 and negative 2/3. Those are the two solutions, the two x values that I just found. Okay, who remembers that one? Factoring, fun. Okay, this next one, I'm going to take out a 2 and take out an x as a greatest common factor. If I divide that out of the beginning, that's just going to leave me x squared. If I divide that out of the middle, it's just going to leave me x. And if I divide that out of the end, 2x divided by 2x is just 1. Now I have to see if this part can go any further. What times what makes 1 and adds up to 1? Well, 1 times 1 makes 1, but does not add up to 1. So there's nothing further that you can do to factor this. So that means that this needs to be done by the quadratic formula. And we go x equals negative b plus or minus square root b squared minus 4ac all over 2a. If I'm going to do the quadratic formula anyways, I'm going to go back to the original equation and just get a, b, c and solve it that way. So a is 2, b is 4, c, oh, we got to take an x out no matter what. So you should be able to do a is 2, b is 4, and c is 2. Or you should be able to do this the reduced version and it would still come out the same. But here we go. Negative 4 plus or minus square root 4 squared minus 4 times a times c all over 2a. Four times 2 is 8. 8 times 2 is 16. So from up here, we get that x equals 0 and x equals 1 as my two possible solutions, which means actually I should have been able to factor it from the get-go. So x equals negative 1, x equals 0 as my two solutions for this quadratic. Let me know if you have any questions on that or feel like you need to remember it. Do you have that formula memorized? Is that something you have on a toolkit? Keep that in mind. All right, this next one, this last one, has a power of 2/3, but first let's get rid of that 3. So the coefficient of 3 gets divided out, and this is going to leave us 16. Now, how do I get rid of a power of 2/3? You could multiply by 3 halves, power of 3 halves to both sides, so that the 3 and the 2 cancel out, just leaving you x. And that's going to leave us at 16 to the power of 3 halves. Well, what does that even mean? Well, it means the square root. Remember, if it was 16 to the 1/2, that would be the square root of 16 to the power of 3. So there's like an invisible index here. So picture stretching this out in pairs. 4 times 4, 4 times 4, 4 times 4, 3 times, because there is a power of 3 there. And you're searching for pairs of 2 for the square root. So take out a 4, take out a 4, take out a 4. And my final answer is just 64. All right, how'd you do on this back page? This bottom section is the type of equations you can expect to see on the final.